Right now, another version of you still exists. 5 years ago, still there. Not as memory, physically there. Physics says your past hasn't disappeared. You're just not located there anymore. Most of us picture time like a conveyor belt. Past behind us, future ahead, and the present is a razor-thin slice we're stuck on. We talk like this all of the time. It happened, it's over, it doesn't exist anymore. But that sentence sneaks in a huge assumption. That time flows like a river, and moments fail off the back end and vanish. Physics doesn't naturally describe time that way. In a lot of fundamental descriptions, time isn't a flowing substance. It's a coordinate, a dimension like space.
Try this. You don't think Los Angeles stops existing when you're in New York. You're simply not there. Both cities exist at the same time. You can only occupy one location at once. Modern physics invites a similar picture. Yesterday is a location in time. Tomorrow is a location in time. And right now is where your experience is located. Now I know the objection, but I can fly to Los Angeles. I can't fly to yesterday. Sure, but not being able to travel somewhere is not proof it doesn't exist. You can't travel faster than light to a distant galaxy either, and that galaxy doesn't vanish because you can't reach it. Constraints don't define existence, they define accessibility. Now we get to the part where Einstein and the physicists after him make this unavoidable. There is no single universal now shared by everyone. In special relativity, simultaneity depends on motion. Two observers moving relative to each other can disagree about which events are happening at the same time. That's not philosophy. That's built into the geometry of space-time, and it's been tested endlessly. Time dilation, particle lifetimes, clocks on planes, satellite systems. So if there's no universal present, then the present can't be the only real slice of reality. It's just the slice you happen to be experiencing. This leads to a viewpoint many physicists discuss, the block universe idea. Space-time as a whole four-dimensional structure, not time-flowing, but space-time simply being, past, present, future, as different regions of the same structure. But wait, if past and future are there, why does time feel like it has an arrow? Why do we remember yesterday but not tomorrow? Why can we unbreak an egg in theory but never in practice? This is where Feynman and basically every good physics teacher brings in entropy. Take a box of gas, start with all molecules in one corner, order, then remove the barrier. The gas spreads out, disorder. Could it happen in reverse? In principle, yes. In practice, the probability is so tiny that you'll never witness it. That's the second law of thermodynamics in the real world. Systems overwhelmingly evolve towards states with more possible arrangements, more disorder. So the arrow of time we feel isn't because the fundamental equations scream forward only. It's because, statistically, disorder dominates. Here's the shocking part. Many microscopic laws look almost the same if you run them backward. Film two particles colliding, play it in reverse. At that level, you often can't tell, so the difference between past and future is not deeply written into every basic interaction. It emerges when you have huge numbers of particles, and when entropy creates records, memories, traces, footprints. We remember the past because the universe keeps producing records as entropy increases. Not because the past vanished, but because the present carries information about it. Now let's ground this in something you can't unsee. When you look at the sun, you're seeing it 8 minutes ago, because light takes time to travel. When you look at a star 1,000 light years away, you're seeing 1,000 years into the past. That star might even be gone now. And yet the past event, star-emitted light, is physically present as photons traveling through space. The past isn't just an idea, it's encoded in signals moving through the universe, and not just light. Gravitational waves are literally ripples in space-time from violent events long ago. We detected them with LIGO in 2015. Signals from mergers that happened ages before humans existed. The past arrives, not metaphorically, physically. Now enter Feynman's signature lens, the path integral formulation. In this picture, a particle going from A to B doesn't choose one clean path. To compute what you actually observe, you sum over all possible paths. Straight paths, curved paths, absurd paths that wander, detour, loop. Most of those paths cancel each other out through interference, and only a small set meaningfully contributes. But the key is philosophical and mathematical. The universe's behavior comes from considering an entire family of possibilities, not a single neat storyline. And in the math, time-reversed contributions appear naturally, not because we can casually time travel, but because the structure of the quantum calculation includes them. Here's one of those mind-bending but real pieces of QFT lore. In Feynman diagrams, you can often represent an antiparticle as if it's a particle moving backward in time, a powerful bookkeeping interpretation that makes calculations cleaner. This is not a YouTube fantasy claim like we prove time travel. It's a tool, an interpretation inside a mathematical framework that predicts experiments extremely well. And those predictions, they match reality with insane precision. So whatever's going on under the hood, our naive everyday story of past disappears is too simple. Now, important clarity. Saying the past exists in a block universe sense does not mean you can go back and change it. In that view, events are part of the structure, fixed as coordinates. You can't rewrite New York while you're in Los Angeles, and you can't rewrite yesterday from today, not because yesterday vanished, but because it's already part of the space-time structure. So, existence is not equal to editability. Now bring it home. Even if you hate the block universe idea, there's a simpler point that survives everything. The present contains physical traces of the past. Your memories are patterns in matter. Your scars are records. The structure of your brain is shaped by previous interactions. And the atoms in your body, they were forged in stars, scattered by explosions, reassembled into planets, oceans, life, you. When you touch a table, you're touching a history, not poetic history, physical history. The past is not behind you, it's embedded in what you are.
So, the next time somebody says the past is gone, you can answer carefully. In everyday life, it's gone in this sense. You can't access it. But in physics, it's not erased from reality like a deleted file. Time isn't a river carrying moment away. It's a dimension in space-time, and the universe keeps records, signals, and structure that preserves what happened. The past still here. In light, in waves, in matter, in memory, in the geometry of reality. And if you want the most mind-bending part next, I show you one experiment that forces you to admit now depends on motion, and the universe does not give you a single universal present.